Hi, hello. So today what we are going to see is today what we are going to see is we are going to see the paths in matrix whose sum is divisible by k, and again this is today's LeetCode strict problem. Okay, so first read out the question. You are given a zero indexed m into n integer matrix and an integer k. You are currently at position 0 of 0 and you want to reach position m minus 1 and n minus 1, which is currently you are at 5 and you need to reach 2. So whatever the matrix, which is the end position and start position and end position. So the condition which they have given is moving only down or right, which means either you can move right or towards your down. So if you are currently at some index or some let's consider at some position of a matrix, either you can move right to that index, or else you can move down to that index. You can't able to go left or top. So that is the condition. So and what the desired result, what they're asking is return the number of paths where the sum of the elements on the path is divisible by k. Since the answer may be very large, we return it modulo 10 power 9 plus 7. Okay, so when it comes to consider this without divisible by k, what happens is, let's consider some of a problem which they are asking to find the number of paths to reach this m minus 1 and n minus 1 only using right and down. What you do is you simply use an dp, you initialize everything with 0. So to reach this node 0, so from here to here it costs 1, and from here to 1 it will be 1, which is there is only one way to reach this 2 and 4. And if you are going down from 5, one way to reach 3, and from 5 0 to reach 0 there is only one way, and you will be starting from here to reach 0. Either you can reach from 2 or from 3, which is you will be adding the total number of paths of this column and total number of paths of this cell and this cell. You will be adding and you will be putting it here. So that's how you will be doing for each and every cell if the remainder, which is the path, is divisible by k, haven't asked for. So but in this problem there is a different case, which means they're asking for the number which is divisible by k. Hence what we need to do is we need to find the number of paths could be reached for each cell for each and every divisible of k. Let's say if it is 5, the divisible which they're asking for 3. So for remainder 0, for remainder 1, remainder 2, remainder 3. So until 3, which is 0, 1 and 2. For remainder 0, for remainder 1 and remainder 2. How many paths are possible for this cell and for 2? So if you are going for 2, for remainder 0, for remainder 1 and remainder 2. How many paths are possible for remainder 0, 1 and 2 for this cell? And if you are going for 4, and same. So you need to calculate the total number of paths for remainder 0, remainder 1 and remainder 2. So you will be doing a DP with different remainder approach. Hence for DP, if you are using without remainder, you will be using 2 into 2. Hence we are here calculating about the remainder. We use a 3-dimensional matrix. Okay, so which is one is for rows and one is for column, and another one is for the remainder calculation. So the remainder lies at 0, 1 and 2, so on, like that. Okay, so after that at each condition what we check is, if you are so there is edge case, so this is a base case, which is you will be traveling either right or down. So while traveling down, you should need to check whether the number of rows is lesser than that row, because if you are at 0, if you are trying to travel below that, there is no rows after 0, then you need to check that. And if you are at 4, you need to check for column whether there is any upcoming columns are there to travel. And once this has been completed, then we can calculating the cumulative thing. So okay, just now I will paste the code and I will explain you. Okay, so I will start it from here. So these are some constants which you are going to use. Okay, so this is the mod operator, which means they have mentioned for large inputs the output would be very long. For that, return it modulo 10 power 9 plus 7. So this is nothing but 10 power 9 plus 7. So we take this a mod and int. Okay, and we created a 3-dimensional DP, as I said, for solving this problem we'll be using 3-dimensional dp, and we had a grid. So this grid is nothing but the grid which they have given this matrix, and k the column which, sorry, the value which they have given. So here this is k, because these are going to be constant, and rows and columns. So for this grid, number of rows and number of columns, we can't able to pass each and every time, so that will be a bit complex. So the number of rows and number of columns will be going to be remain same for each and every calculation, so we make it as a constant variables. And so before going to dfs, let's come to the number of paths. So here we have assigned the values for each and every global variable which we have created here. So for those global variables, so this dot grid is equal to grid, and this dot k is equal to k, and this dot row is equal to, so length, the number of rows, and this dot column is equal to columns, so number of columns we are assigning that. And after that, for a dp, as I said, we are creating a dp which is int rows, columns, and k is nothing but of, if k is 3, 0, 1 and 2. So for remainder 0, remainder 1 and remainder 2, we need to calculate the total number of ways for each and every cell. After that, we are filling the dp with -1. So for int I is equal to 0, number of rows and number of columns. So this is simple nested for loop, and if we are filling using arrays.fill for each dp of I comma j -1, because so after you are doing so nested, so 0 comma 0 itself, it's an array, because it is a 3-dimensional dp. So if you are traveling to if you are doing in two nested loops, sorry, using a two nested loops, what happens is you traveling and you found an array. So for that array, you will be filling the entire elements of that array is -1. So for now, what we have is, we have an dp which has -1 values, which is the total number of cells in that dp is equal to number of rows, which is, let's consider as m, and number of columns, which is n. So this will be like normal 2dp matrix cells, and hence we have a 3-dimensional array. It will be into k, which is m into n into k number of cells will be created in this dp. Okay, after what we do is we start it from here for start rem grid of modulo by 3, which is for first we are starting from the remainder of this cell. So this is the starting point. So we started a dfs here. Now we can go through the dfs function. So if you go through the dfs function, what you need to check is whether you have reached the end node or not. If you are reached the end node, and what we need to check is whether the remainder of that end node is equal to 0, then that path is valid. So if that path is valid, we need to return 1. If that path is not valid, we return 0. Okay, so that is what we are doing here. We check whether the current row is equal to rows -1, which is the last row, and the current column is last column. If the current row and column is last row and last column, what it means is it is at the end position is m-1 and n-1. So we check for the remainder modulo 3 is equal to 0. So in this case I am saying 3. So the normal case will be k. If remainder modulo k is equal to 0, we say we return 1, or else we return 0, which means we are checking whether that path, the sum of that path has the sum of that path is divisible by 3. If the sum of that path is divisible by 3, we are returning 1, or else we will be returning 0. Okay, now what we are checking here is, so we are using a memorization, hence we are using a dp. What happens is, in some cases, so let's say you are calculating the remainder of 3 4 0 by the path of 5 3 and 0. So again, so you are coming to 5 2 0. What happens is, already the remainder for 0 has been calculated, so calculating it again would be waste of time, so we are using them. So if that user is asking for dp of r comma c comma rem, and it is not equal to -1, hence if it is not equal to -1, we have found the value before itself, so we are simply returning that. Okay, or else we need to find the value for that. Okay, now what we do is long ways is equal to 0. So for if row is, so we are doing a backtracking kind of here, which is top down dp. This is if rem, which is if row is lesser than if current row is lesser than the number of rows, what we do is we say int new rem is equal to, so this before remaining, and we add the current cell value, we are adding the current cell value and modulo it by 3, and again send it to the base plus dfs of r plus 1 c plus and new rem, and again we checking it for columns, which is if you are like checking it for columns, you are moving towards right. If you are checking it for rows, you are moving towards down. So is c plus 1 is lesser than columns in them is equal to replace the grid of or c plus 1 modulo by 3, and after that we are passing it here.